Hello, everybody, and welcome to the first and probably only episode of Robbie and Gian try to figure out how to keep a camera propped up while they write. In this case, I've got a pretty janky Lego stand, but it works for now. This is gonna make Sal Khan look like a preschool teacher. Okay, so question number 5. A 60 kilogram box sits on an incline of 14 degrees. A rope pulls up the ramp with a force of 20 newtons parallel to the ramp. The ramp has coefficients of friction, has a coefficient of friction that is 0.14. Which way does the mass move and what is the acceleration? So let's start off with a free body diagram. So let's get myself a point right there. That's going to be our box. So right off the bat, we know that the force of gravity on this box is going to be 588 newtons. I got that number by multiplying 9.8, which is the force of gravity on Earth and acceleration, by 60 kilograms, which is the mass of the box. Then let's draw our little incline. So we've got down the incline and up the incline. And if you draw in a little dotted line here, this is going to be our x-axis. And we're told that the ramp is 14 degrees above the horizontal. So that is a 14-degree angle right there. Let's give these little arrows because eventually they're going to be quantities. So normal force, what do we know about normal force? Well, it's perpendicular to the thing that the object is sitting on. In this case, that's the ramp. So perpendicular to the ramp, we've got an arrow coming out. We'll talk about how to get that actual number in just a sec. But first off, we know we have a force of 20 newtons pulling us up the ramp. That goes right here. Now we have to figure out the force with which this thing wants to slide down the ramp and the normal force. Okay, so cut 2. You may have noticed this just magically appeared. The way we calculate our normal force is by taking the cosine of our angle above the horizontal here and then multiplying that by our gravitational force on the object. So in this case, that is 588 newtons times the cosine of 14, which gives us 570.53 newtons as our normal force. So that number we can put right here. And then we need to go ahead and figure out the applied force due to gravity. So that is how much gravity is tugging this thing down the ramp. And to do that, we're going to take the sine of our 14-degree angle, and we are going to multiply that again by our 588, which in this case yields, let me just put in newtons there. In this case, that yields 142.25 newtons. So let's put that right here, 142.25 newtons. So in the next section, Gian will be covering whether this box is actually going to go anywhere. But for now, let's move the camera. That is our free body diagram as it stands. Remember, we have our gravitational force. We have our normal force perpendicular to the surface. We have the applied force, which is 20 newtons tugging this thing up the ramp. And we have our force pulling this thing down the slope, which is gravity, of course, and that's 142.25 newtons. So I will hand this over to Gian.
Hey, Robbie, how are you? Yeah, I'm doing good, Physics project? Physics for when is that due again? When is that due? Thursday. Oh, okay. Yeah, no, of course I started. Of course, yeah, I totally started, yeah. Yeah, I'm done. I'm done. Yeah, I'll edit the video. I'll call you back. Yeah, I'm done. We're done. Okay, we need an idea, like right now. We have like half an hour, man. We gotta step it up. Come on, ideas.
I'm just the editor, all right. You're the ideas guy. You're the face on the video, whatever. Okay, I just edit the video. Don't look at me. Don't look at me.
What if you do like that physics tutorial video, like flipping physics, where you edit me like 3 times over. You have to just edit me 3 times over. Yeah.
We've already procrastinated until half an hour before the deadline. You think I'm gonna... Okay,
No way.
fine. I'll improvise. Alright, we'll figure it out. Let's go with it. Put a suit on, and then we'll talk about it. Alright, fine. This better work.
Flippin' physics.
Alright, good morning, class. How are we today? Yeah. Mr. DePitos? Yeah, where are these two? They're not here. Yeah, they're actually both on a field trip right now. They might come back at varying intervals, whether or not you're in the room. But yeah, it might happen, might not. We'll see.
They're both on a. That's just lazy writing, man. Come on.
Anyways, we'll just take Robbie's notes here. And we have force of weight and we have force natural. And right now, what should we do? I think we should probably calculate force of friction, right? Because there are only so many things we can calculate right now. And I think since we're feeling a little bit stuck, that could help. So how do we calculate force friction?
Yeah. So, since friction force is equal to force natural times mu, and Robbie's already calculated force natural, then we can just multiply that by mu to get force friction.
Excellent. So go ahead and do that calculation. Now I'll write it down here. And what do you get for force friction?
$78.87 newtons.
All right. So we have the force of mu, which is 0.14 mu, times 570.5, which is our force natural, is equal to 78.87 newtons, which is our force friction.
Can I go to the bathroom? please?
Yeah, of course. That's convenient timing. Oh, wow! Look at that. Look who it is.
Yeah. The field trip was litty, no cap.
Well, we have the force of weight, and we have the force natural, and we also have the force of friction. However, I still don't think that's enough to solve this problem, because we know how much force is being applied in the upward direction, right? And we know how much force friction is trying to counter it, but we don't actually know how much force is going in the other direction, which is what we're going to need to see which way the box is moving. So how do you propose we calculate that?
Well, now that we got the friction force, and now we know how much force is being applied, all we have to do is see how much force is being applied in the other direction. So all we'd have to do is take the natural force, which is 588, and then we just gotta take that and then do sine 14, and then that is equal to 142.2 newtons. So all we have to do is just put force natural in front of sine 14.
All right, that's great. So I'm going to go ahead and write that down really quickly. 588 sine 14 is equal to 142.3 newtons is equal to the force applied in the other direction. Now, we have up and we have down. So the question is, which way is the box actually traveling?
Well, that's easy, man. All we gotta do is see if the force of it being pulled up the ramp is greater than the force of it being pulled down the ramp. And as you can see, 142.3 newtons is greater than 20, which means that the box is actually going to go down the ramp instead of up.
All right, perfect. So the box is going downwards. That is a huge step in the problem. That's actually one of the questions. So we already have an answer. It's going down the ramp.
Bathroom. Yep.
All right, yeah, I see you. Wow. Unbelievable timing. I wonder what's going to happen. Oh, look at that. Look who it is. Oh, my.
Hey, morning.
All right.
Sorry, I'm late. I had the field trip. So, anyways, let's look at the problem. Alright, so we know that the box is going down, which means we just have to subtract. So we take 142.3, right? 142.3. And then we subtract the 20 newtons of it being pulled upwards, and then we also have to subtract the friction force, which is 79, yes, 79.87, which is 42.43 newtons going downwards. Alright, perfect. Let's write that down. We have 142.3 minus 20 minus 79.87 is equal to 42.43 newtons. However, the question isn't actually asking for newtons. It's asking for the acceleration of the box going down the ramp. So how do we calculate that? Well, to calculate acceleration, all we have to do is use force equals mass times acceleration. It's easy because we know force, and then we know the mass of the box, and we just have to calculate for acceleration. So then we just... Oh, you want... Okay, so, force is equal to 42.43, and then,
the mass of the box is equal to 60 kilograms. So we should have to take those two numbers and divide. And we get 0.0. Oh. We get 0.707 meters per second squared, dog. Okay, I think we're good on takes. I think I can edit this, but just can we just get a take of you saying down the ramp?
Dude, I read the
I think
script.
I forgot to
you
say
know,
down the
like
ramp.
I read that
Yeah,
script.
we're gonna
perfectly.
just-
If you want me to say something, then
okay,
put it in
I'm
the
sorry.
script.
Just down the ramp. Just once. Down the ramp. Down. It's 0.707 meters per second squared down the ramp. It's going down. All right, man. We did it. That's the last take. All right, we can start. I can start editing now.
Thank God.
Yeah, let's go. All right.
go.
How much time do I have?
Oh, son of a...